Hi, it's Sam. In this video, we're going to revisit the note quantization or scale quantization code that I first demonstrated in an earlier tutorial because I can improve it with you. The original code I had made when making a device that I generated the MIDI pitches myself. I wasn't using a MIDI keyboard to input the pitches, and then I was sending them to a make note and note out. And note out automatically sends note offs after a set duration. The problem with that approach that I showed in that video, that previous tutorial, is that note offs may not be sent to the correct note when you change the scale, when you're holding down and then releasing a note. So if you hold down a note, then change the scale, and then you release that note, it might not be mapped to the scale the same way, and so you might not get the note off message. And that wouldn't have happened with the code that I had used because I was using make note and note off, but and make note and note out, which automatically sends the note off, like I said. But if you were using MIDI input like a keyboard, then you could have this issue. So I'm going to try and fix that today with some new code. And so we're going to begin by making 2K sliders so we can see what the input and output looks like, make sure it's correct. And let's just go into the inspector and turn these on polyphonic mode. And the first thing we're going to do is, well, basically I want to have two different kind of workflows here. The first is when there is a note on. With the note on, we're going to quantize the pitch. And so this will be note on, quantize pitch. The second thing that's going to happen is that we are going to have some other code that's going to handle the note offs so that we can avoid the issue I discussed earlier. So let's just start with the note ons over here. So we're going to pack the velocity and pitch from the K slider together. And we're first going to send this list of the MIDI number and the velocity to our pitch quantization code. Then it's going to go over to the code that's going to help us with the note ons and note offs. But we're just need to unpack this. And we need to determine if this is a note on or a note off, because we're only going to quantize the pitch if it's a note on. So we're going to first take the velocity and check if it is greater than 0, which means it's a note on. And if so, then we're going to send it to our scale quantization code. So let me just make a dummy subpatcher here. This is our scale quantization code. Actually, let's add an inlet and an outlet for that. So we're going to send in our pitch only when it's a note on. So we're going to use a gate to make sure the pitch doesn't go through if it's a note off, because again, we're going to be handling note offs separately. And then that's going to go into our scale quantization code. From there, we're going to take our quantized pitch and first pack it into our note on message, retrieving the velocity from here, and put that in the cold inlet when we initially check if it's a note on or note off. That way we can make sure not to send this through. And then send that to the K slider, so send that out. And then this will also go to our other code later. So let's just make sure that we have this correct. We're sending it to an unpack to check first the velocity if it's a note on. If it is, we let the pitch go through, we quantize the pitch, and then we pack it together with the velocity and send it through. So this is basically what we had before. So let's just go through the code for quantizing the scales again. And actually first I want to make a menu, two menus outside of this code using uMenu for the current root and for the current scale. And we're going to send this to the scale quantization code. So for the current root, we're going to go into the inspector, go to menu items, and separate each item with a comma. We're just doing the root, so C, C sharp, D, D sharp, E, F, F sharp, G, G sharp, A sharp, B. So now we have C through B, and this will be 0 through 11. That's the index that's coming out of the first outlet. That'll be what our current root is set to. And then the current scale, for simplicity's sake, let's just do 2. We're going to do chromatic, and major. And so again, we're just using the first outlet for the index, so 0 for chromatic and 1 for major. And that's all we need for that. So going into our subpatcher, let's make the scale quantization code again. And this will be the same as what I had before, more or less, from the previous tutorial. So we're going to take the current root and the incoming pitch, MIDI pitch, we're going to subtract the distance from the current root. So for example, if this was middle C and the current root was C, which would be 0, then we're not subtracting anything. And so we're just letting it go through a C. This is because we want to subtract the distance from C to transpose it in terms of C. So, if C is selected, okay, C is 0 away from C. C sharp is 1 away from C. So, and then we'd get 1 if the current root was C sharp. And then if we make everything in terms of C, that makes it really easy to just map the incoming pitch to the scale, and then we can just add back in the amount that we subtracted initially. So we're going to then take this offset pitch, and we're going to strip away the octave information using mod 12 and send that to a ZL lookup. So ZL lookup, ZL for doing modifications or transformations, whatever it might be on lists. Lookup is going to take in some number, some address, and it's going to look at that position. So if it's like 0 and we have a list of 1, 2, and 3, then 0 would be the first number, 1 would be the second number, 2, and 2 would be third number, 3, etc. So we're going to use this as a lookup for the scale, which we'll put in here. And then we can add back the octave information we took away. And to get that back, we're just going to divide by 12. And then we're going to multiply by 12 and make sure that these have to be integers. So make sure you don't add a decimal point. Okay. So now we've got the octave information back that we stripped away using mod 12. Now we need to get the offset information back from when we subtracted the current root. So we're just going to add back the current root. And then we can send out the pitch now that's been quantized. However, we also need to account for the scale. So we're going to get the current scale, and we're going to use that as the address for a col of scales. And I think I should embed this in the patch so that I ensure it gets saved with it. So add embed 1, and then let's open this up. And we only have 2 options for now. You can add more if you'd like. So for chromatic, we're going to have address 0, so 0, comma, and then it's just simply going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We don't make any changes, so every pitch is just mapped to the respective linear other pitches. There's no changes happening, no transformations happening here. Then we can go to the first address. This will be, well, this is address 1, which is actually the second address, and we are going to put them kind of mapping for the major scale. So the first would be 0, and then the second would be 0 as well, and then 2, 2, 4, 5, 5, 7, 7, 9, 9, 11. Okay, I think I got that right. So the idea here is that if C comes through, then the first position is 0. So, and C is again represented as 0. So that makes sense. We want to map C to C. But C sharp is not in the key of C major. And so in the second position here, we have 0. So mapping C sharp to C instead of to C sharp, because that would not be in the scale, and so on. So if the incoming pitch is not conforming to the scale, this is how we're going to remap it to whatever it should be. Make sure if we have a semicolon at the end, that we're going to close the window and hit validate. And then let me just check it worked. Okay, great. So now that we have that saved in, we should be able to close this just fine. And let's just make sure that we maybe select chromatic or major and then like C, just make sure that's all initialized in there. And now we can move on to the other set of the code, which is going to be handling the note off messages. So what we're going to be doing here is using borax, and borax is an object that reports note on and note off information, as the description says. And what we're most interested in here, or really only interested in here, is the second outlet, which gives a voice allocation number. So it gives a number associated with whatever the incoming pitch is. And then it also gives us a velocity, right? The incoming velocity, which we're going to use as well for determining if it's a note on or note off. And we're going to send this, the incoming pitch and velocity is going to be sent here after all this code. Remember that for trigger, all the code that is sent out of the first trigger will happen first, all the way down, and then the next part of trigger, or the next outlet, and so on. So in whatever order it's being sent out, all the code will be processed before moving on to the next. So now that we've sent that to borax, we're going to have 2 kind of conditions here. First, if it's a note on. So if it's a note on, we're going to save the quantized pitch in col. This is going to be a second col we're going to be using the voice number as the address. So that means we can then retrieve that pitch when it comes to the note off. So for note offs, we are going to retrieve the pitch from col using the voice number, send a note off, and then remove it from col. So those are our steps. So to figure out if to note on or note off, we're going to be using the velocity outlet. So if it's a note on, it's going to be greater than 0. If it's a note off, it's going to equal 0. And we're going to use these conditions to test a gate to decide if we should send to col or not. And col is just going to be, let's say, incoming notes. And we don't want to embed this in the patch because this is going to be changing as we send notes to it. Nothing needs to be saved with the patch with this. And so when we have a note on, we want to save the quantized pitch with the voice number. So the voice number is being used at the address. So if you remember, for retrieving information from col, you use the use address to retrieve the contents at that address. So we're going to use this address, which is going to be the voice number. Oh, actually, that's what we're doing for node off. I guess I should say that for node off. So for the node on, we're going to be using the address to save. So if we're going to save with it, we're going to pack together, 0, 0. We're going to pack together the voice number, which is the second outlet, with the quantized pitch right over here. So we're only going to send this through if it is greater than 0, if it's a note on. Then we can send through the voice number as the address and the quantized pitch as the content, or what's going to be saved at that address. If it's a note off, like I mentioned, we want to, well, let's use this for the gate. And we're going to want to use the address to retrieve the contents. So we're only going to send out the voice number if this is a note off. Now, when we do that, we will send out the data from the address. And it's going to come out the first outlet. When we're just saving the data, that's not going to happen. But when we're trying to retrieve it, it's going to come out the first outlet. And so when that happens, we're going to want to append 0 to the pitch so that it becomes a note off message. And then we're going to want to send it to our output, or in this case, the case slider, to turn that note off. Then we're going to need to remove that address, or I guess the contents of that address. And to do that, we're just going to use the second outlet of col, which gives us the number or symbol associated with the data. In this case, that is the voice number. And we're going to use that to remove that data. So we're going to send this into col. And then that will remove that note now that it has been, now that we sent the note off message. We don't need to keep it stored in col any longer. So let's give this a try. Let's see, C and chromatic. So what we're expecting here is that the input and output should match, which it does. Now, if I hold something like F sharp and then change to major, F sharp is not in the C major scale. So when I release it, it should, yep. So now it was cleared. So even though F sharp is not in, it was in the chromatic scale, but not in the major scale. But since we're not mapping this F sharp to F in our scale quantization, and because we're using borax to find what we mapped that voice to, we're able to remove it that way. So now, if I try something else, like I get, I don't know, G sharp and D sharp, and then I switch to major, remove G sharp, remove D sharp, and it works. So it works with polyphonically as well. Great. So using this, hopefully you can find some interesting things to do with this quantization code. Hope you have fun using it in your own projects. Let me know if you have any questions or anything else you'd like me to cover. Otherwise, until next time, class is dismissed.